This video is on union and intersection of sets. So there's a couple things that we want to know first off. One is that the term union usually gets associated with the word or, because for union all it has to be is that the element has to be a member of one set or the other. It does not have to be a member of both sets to be a member of the union. Intersection gets associated with the word and this is because to be in the intersection, a number has to be an element of both sets. If it's just in one set, it's not included in the intersection. So we have two sets here, M and N. And in part A it asks us for M intersect. And we've got this upside down U symbol to represent intersect. So M intersect N. And I just like to write the word and in there somewhere to remind me that it has to be a member of M and N in order to be a member of the intersection. So what I do is I start with my first set, M. And I look at each element. So -3 is an element of M. And then is it an element of N? Yes, it is. Since it's in both sets, it's included in the intersection. Then I move on to the second element of M, -1. Is it an element of M or N? Yes, it is. So it's included in the intersection. Then I move on to the next element of M, which is 1. And you'll notice that 1 is not anywhere in my set N. So it's not included in the intersection. The next element of M is 3. Once again, it's not in N, so it's not in the intersection. And then the last element of M is 5. Once again, 5 is not in N, so it's not in my intersection. So M intersect N just consists of two elements, -3 and -1. There's only two elements that are in both M and N. In part B, we've got M union N. So this means or. So we want every number that's either in M or in N. It does not have to be in both. Well, if that's the case, then the first thing I do is just write down all the elements of the first set, M. -3, -1, 1, 3, and 5. Since I know they're an element of M, then they have to be in either M or N. The next thing I do is I look for any elements that are in N that weren't in M. So for instance, this first one here, -4. I need to include that in my union because it's in either M or N. -3 I've already written down right here, so I don't need to write it again. But I have -2, so I need to write that down. -1, once again, I've already written down right here. And then I've got 0. So since I haven't written that down yet, it needs to go into the union. So now we've got this set, -3, -1, 1, 3, 5, -4, -2, and 0. Those are all elements that are either in M or they're in N. And that's the union of the two sets. So union and intersection isn't too bad if the sets are finite, but it's a little bit trickier if the sets are infinite sets, if they contain an infinite number of elements. And this can usually be helped by graphing. So in part 2, they give us 4 sets, A, B, C, and D. And they want us to graph the sets and then express the answer in both set builder and interval notation. So the first one we're asked on part A says graph A intersect B. So I'm going to just write and to remind myself that A intersect B means that the elements are both in set A and set B. The other thing I'm going to write next to this is overlap. Because if I'm looking for the intersection, I'm really looking for where these two graphs are going to overlap. So first I'm going to give myself a line that I can graph on. And I'm going to remind myself, I'm looking for the overlap here. So the first one I want to graph is A. So that first condition for A says x such that x is greater than negative 3. So here's 0. Here's negative 3. And since x is greater than negative 3, I'm going to go to the right. And since it's strictly greater than, I'm going to use a parenthesis. For B, it says x is less than or equal to 0. So I'm going to graph slightly above my line. And it's going to the right because it's greater than. Now it says x is greater than or equal to 0. So I'm going to use a bracket. And now I can see that these two lines overlap right between the symbols. So the interval notation is really easy to write. The interval notation is simply from negative 3, using a parenthesis because we don't want to include it, to 0. If we want the set builder notation, then we start with x such that, and now I'm going to put an x kind of off to the side in the middle because we know we want x to be greater than negative 3 and less than or equal to 0. Now, when it asks for A union B, we can actually use the same graph that we just used, but what we're really looking for is the entire graph, because the union means or. So we can see, let's go ahead and just graph this again. A was all elements that were greater than negative 3. So I put my negative 3 here. Greater than negative 3 goes to the right. So I know I'm getting everything to the right of negative 3. For B, I'm getting x is less than or equal to 0. So I start at 0 and I go all the way to the left. So if I'm looking at my entire graph, from here on, I catch all elements that are greater than negative 3, and from here on, I catch all elements that are less than 0. That means that if I'm looking for only one of the two sets, using both my sets combined, I catch every single real number. I've graphed the entire number line. And since they only have to be in one set or the other, that means that the union of A and B is the entire real number line. So my interval notation goes from negative infinity to positive infinity. And there's a number of ways of doing the set builder notation. But the way I like is to simply say x such that x, you can either say is a real number, or if you want to be a bit more mathematical, you can say it's all elements x such that x is an element of, and that's this kind of funny E symbol for is an element of, and then we draw an R, and the R has two bars right here. And that says x such that x is an element of the real numbers. And you can do it either way. This way here is perfectly acceptable. This way here is just a bit more formal and mathematical. Alright, so now we're going to move on to B union C. So first I draw my graph, just a line here so I have something to graph on. And we start with B. Now this is union, right? So this is OR. We want the overlap. Or not the overlap. We want the entire graph. So it only has to be in one set or the other set in order to be in the union. So I'm going to start by putting 0 on my number line. And then I'm going to go back to the top and look at it. It says B equals x such that x is less than or equal to 0. So less than means the arrow goes to the left. Less than or equal means I want to include that value. Now if I look at C, there are two conditions on C. So I want to write these both down. So if I'm looking at C, then the first condition, if I'm reading this way, says x is greater than or equal to -1. So x is greater than or equal to -1. And the second condition is x is less than 4. So if I look at it, say here somewhere is -1, and here somewhere is 4, x is greater than or equal to -1, so it's above -1, but it's less than 4, so it's going to stop at 4 and go the other way. So since I want B union C, that means it just has to be in one or the other. So I can see that in terms, there's nothing over here. Neither of my graphs hit anything to the right of positive 4. But I can see that one or the other of my graphs hits everything from 4 all the way down to -infinity. So B union C would be from -infinity up to but not including 4. And the way that we would say that in set builder notation is that we want all elements x such that x is less than 4. Alright. So now what we want to do in example D is we want to get the intersection, which means and, or overlap. So we want all elements that are in B and also in C. So if we draw our graph again, we know that B is less than or equal to 0. And we know that C is between -1 and 4. So between -1 and 4. Now, it says x is greater than or equal to -1. So we know we're going to use a bracket here, and x is less than 4. So we'll use a parenthesis there. Now you'll notice that when I draw this in, right here, between -1 and 0, that's the only place where the two graphs overlap. Remember that in order to be in the intersection, they have to be in both sets. So the intersection, or the overlap, is from -1 to 0. And we used brackets because there was a bracket at -1 and a bracket at 0. So we really want, what this intersection is saying is that we want all real numbers between -1 and 0 inclusive. So to do this in set builder notation, we say x such that x is greater than or equal to -1 and less than or equal to 0. And that's our set builder notation. Alright, so we've got two more examples that we want to do. B intersect D. So once again, this is the AND or the overlap that we want. And then off to the side I draw my line. And we graph first B. B says x is less than or equal to 0. Less than goes to the left, or equal to means we have a bracket. The set D has two conditions. X is greater than 1, and it also has the condition that x is less than 3. So here's 0, so somewhere here is 1, and we want it to be greater than 1 but less than 3. So really it's between 1 and 3. Now one thing I want you to notice is that this right here represented the set B. And this right here represents the set D. So we can see that there's a little space in here, right? There is no overlap between these two sets. For the intersection, we want the overlap. Since there is no overlap, we call this the empty set. And the way that we show an empty set is just by making a set with no values in it. Alright. Now if we wanted to do this in set builder notation, there are no elements in here. So, set builder notation would still be something like this. Yes, this is the empty set. So those two answers would actually be the same. Because, if we go like this, x such that, we can't have an x. So we could say x such that x is an element of the empty set, but that's kind of nonsense. So we would just kind of go back to the empty set. Alright, last one. A union D. So remember, union means or, which means it only has to be in one set or the other. Draw my line here. Now the first set is A. So if we go back to A, right here, it says x is greater than -3. So here's my 0, here's my -3, and A is strictly greater. So we draw our arrow to the right, and we use a parenthesis. For D, we know that it's between 1 and 3. So here's 1, here's 3, and it's between them. Well, you can see that the second set we graphed, between 1 and 3, is actually contained within the first set because it's greater than -3. So to get our interval notation, we say that it's from -3 to infinity. And our set builder notation is going to look just like A because it was actually contained in A. So it's x such that x is greater than -3. And that's it.